Hello everyone and welcome back to another problem of the day, and today's problem is titled Counts Zeros XOR Pairs. In this problem you are given an array of size n and your task is to find pairs ij such that a of I XOR a of j equals 0. So for the given example with the elements 1, 3, 4, 1, 4, the number of such pairs is 2. And what are those pairs? Those pairs are the number 1 and 1 and 4 and 4. So these two pairs form the result. So let's first understand what XOR is. So XOR, it simply means that if both the bits are same, then the resultant value would be 0, and if any one of the two bits is set, then that value would result to be set. So for example, if my first bit is 1 and my next bit is 1, then the value would be 1. If my first bit is 1 and the next bit is 0, then my value would be, well, I wrote it wrong. The value would be 0 and not 1. And if my first bit is 1 and the second bit is 0, then my value would be 1. And similarly, if my first bit is 0 and the second bit is 1, then the value would be 1 itself. And if both the bits are 0, then my value would be 0. Now using this, if I say two numbers of the same value, that is 4, which can be represented in binary as 100, and if I XOR them, then I'll simply get the value as 000 because all the bits are same in the same position. So using this, we have to find number of such pairs. Now let's write in the example first. So what is the example? 1, 3, 4, 1, 4. 1, 3, 4, 1, 4. Let's keep in another 1 to understand the problem better. Now they have asked us to solve this problem in O of n log n time. The immediate thing that comes to my mind, if I have to solve it in O of n log n time, I have to sort it, because by sorting I get the elements of the same value closer together and it would be easier for me to compare. So after sorting, I'll get the array as 1, 1, 1, 3, 4 and 4. After sorting, I'll take in two variables, I equal to 0, j equal to 0, and using I and j, I'll be comparing the elements with the same values. So initially my I would be placed here, right? Now using I'll compare array of I with array of j. Since both are at index 0, they are same. So my count would be 1. Now I'll increment j to 1. So I'll increment j equal to 1. Now comparing this value with the previous value, that is array of I, which is at index 0, and array of j, which is at index 1, I'll get the same value. So I'll increment my count again. Now again I'll increment j to 2, and I'll compare array of j, that is at in position 2, and array of 5, which is at index position 0. I'll compare them. Again they are same, so I'll increment my count. Now after incrementing, I'll again increment my j. It would be 3 now. Now j points at the value 3. If I compare 3 with 1, since they are not the same, I'll break out of the loop and I'll simply count the number of pairs uh, that is formed using these three elements. So to calculate the pairs, I'll simply use the formula. Since we have the count to be 3 of the same value, that is of 1, I'll use the formula 3 times 3 minus 1 by 2, which gives me 3. Now after doing this, I'll simply reset my I to be j. Now j here in this case is 3. My I would be 3 and my j would also be 3. Now again I'll do the same operation. I'll compare 3 with 3 itself. The count is 1. So the count is 1, and I'll again move ahead in one. I'll move ahead j in by 1. So my j would be 4. Now after moving j, since 4 and 3 are not equal, I'll get the pair value for the element 3 to be 1 times 1 minus 1 by 2, which is nothing but 0. Now after doing this, I'll move ahead. I'll reset my I to be at index 4, which is same as that of j to be at 4, and I'll again perform the same operation. Now comparing 4 with 4 itself, I'll get the count as 1. I'll increment my j with 2, 5, so my j would be here. Now again comparing 4 array of j with array of I, I'll get my count to be 1 since they are both equal. And after doing this, since we have reached the end of the loop, I'll simply count the pairs, and the pair would be 2 times 2 minus 1 by 2, which is nothing but 1. So my total result would be 3 plus 0 plus 1, which is nothing but 4. So there are 4 such pairs whose XOR value result in 0. Now let's translate the algorithm to code. First of all, we have to sort our array. So for that, I will use the stl sort function, pass in the array and the size. Now let's call in another variable pairs and initialize it with 0. Now let's loop over the array itself. So we'll have int I equal to 0, j equal to 0, and I less than n minus 1. We are comparing, we are iterating I till n minus 1 because it is our index j which would be performing the compare operation, and we would be incrementing a j. So every time we find a pair which is not equal, we'll be resetting a j. That's why we'll be writing a equal to I equal to j as our incrementing condition. So now we'll be comparing array of I with array of j, and if they are both equal, we'll keep on incrementing our j till we reach a point where our array of j is not equal to array of I. And if that is the case, then we'll simply count such similar pairs, and that would be by subtracting j with I. After finding the count, we'll simply add it on to our number of pairs, and we'll use the formula count times count minus 1 by 2. Now after this, we can simply return the pair. Let's try and compile. There's the error. Oh, all right. All right. So that was it for today's video. If you have any doubts, you can ask them in the comment section. And thank you for watching.